Welcome to the tree math section of the video. Let's jump right into it. Okay, so let me draw a basic tree that we are going to make. This is what it's looking like, right? We have these three pieces with some overlap and a base here, right? Now, the question that we all have is how do we know the sizes of each piece basically? And how should I measure that, right? So we need four things to know that. The first thing is the height. What is the height of this tree that you want to be? The second, oops, sorry. The second is the top angle, which is this angle here. What should that be? And third is, let's say, number of pieces. By pieces, I mean the side pieces. So for me, it would be like three pieces here, right? So this will be three. And the number fourth is overlap between those pieces. So if you can see here, we are planning to have some overlap between these pieces here, right? So that's the overlap. So I have assumed for my tree, my height is 3 feet or 36 inches, top angle to be 45 degrees. Number of pieces is 3 and overlap is say 2 inches. Okay, so that's the assumption that we are starting with. You guys can obviously vary uh, according to your tree. So right from the start, we know that this is like a triangle basically, and actually an isosceles triangle. An isosceles triangle, if you remember, has two equal angles. And we want our Christmas tree to be symmetrical, so it has to be isosceles, right? All right, so in isosceles triangle, two angles or two sides are equal. So we know this angle is 45 degree. So what should these two angles be? We also know that in triangle, all three angles should equal to 180. So 180 is 45. Don't solve this. 1 second. 2x, right? So x is 135 by 2, which is 67.5. So these two angles are 67.5 degrees, just for our understanding. So that's one thing that we know, right? Now, if we draw a perpendicular line like this here, right? So this is 90 degree here. So now we have two triangles. And now we can use some of the other properties of a right angle triangle. Now we have two right angle triangles, right? So from the middle school, you must remember some of the laws. So this angle now becomes 22.5 because it is half of 45. So this is now 22.5. This is 67.5, right? Now, for right angle triangles, if you know one side and one angle, there is a law that you can use to find the rest of the sides. We used to learn it as SOHCAHTOA. I don't know if you guys did the same. It's written like this, which means a sine theta is opposite by hypotenuse, cos is adjacent by hypotenuse, and tangent is opposite by adjacent. So since we know this is 67.5, or if you want to use this is 22.5, we are interested in this hypotenuse basically, because that's where we want to cut the pieces, right? So we can either use sine of this, because we know this is 36 inches, this side. So let's use sine theta is opposite, which is 36, divided by hypotenuse, which we don't know. Therefore, x is 36 divided by sine of 67.5. Wow, my handwriting is terrible, but all right, let's see what is sine. Oh. So 36 divided by sine of 67.5. Make sure that this is in degrees and not radians. So this is in degrees. That gives it 38.966. I'll round it off to 39. Okay, so x is 39 inches basically. Okay, we solved most of the part. So now only thing remaining is we now know we need 3 pieces, right? And with 2-inch overlap. So let's just take this right angle triangle here just to focus on it. We found out that this is 67.5, this is 22.5. Now we know this is 39 inches and this is 36 inches. But ours is not a single piece of wood here. We have 3 pieces. And assuming we want 3 equal pieces of wood, like, lengthwise. So what we should do is, and we also have 2-inch overlap. So I'm going to draw it here so it is easy to visualize. This is how it is actually. So we have this overlap pieces here and this. So if assuming we want this piece, let me color it with yellow. If you want this piece, this piece and this piece to be same, I can say that x plus, assuming that is x, 2 inches of overlap plus another x plus 2 inches of overlap plus another x is 39 basically. What I'm trying to do is I'm just visually seeing it like this is an x, this is 2-inch overlap, x, 2-inch, x, right? 39, which makes it 3x plus 4 is 39. Wow, this iPad is really smart. 3x is 35. So x is what? 35 divided by 3 is 11.66. 11.66 inches. That is for x, but we have 3 pieces and they have overlap. So this first piece here, let me use a red color. This piece here will be x plus 2 inches, which is 13.66. This piece here will be x plus 4 inches because it has 2 overlaps on the beginning and the end. So this becomes 15.66. And the last piece, same as the first one, x plus 2, so 13.66 inches. So that's it. Those are the measurements of these 3 pieces that you want if all these other parameters are true. Only thing you have to take care is that on the other side, let me draw it with green color. On this side, when you calculate like this, these 2 pieces will be exactly same. So you need these 2 pieces. But the top piece, you will have to cut a bit shorter. How much short? The thickness of this piece. So this piece here will be x plus 2 but minus thickness of the piece. Thickness of this piece basically. So this will be 13.66 minus, if it is a 1-inch thick wood that you're using for the whole tree, then it will be -1. So this would be, the length would be 12.66 basically, only for this top piece, which makes the 45-degree angle here. Rest, the measurements are the same. And okay, so one more thing pending is the base. How do you calculate the base? I mean, you can do math to calculate the exact base, but I would just, glue these pieces together first and then uh, put it on a word, just mark it and just cut on that. Don't need to do math on that. But this math would help, like if you want to have a certain look. So for example, you can change this parameters. Instead of 3 pieces, if you have like say 2 pieces instead of 3, then this would change, right? So you can design your tree the way you want. Same is the case if you want a slightly narrow tree. You can have, instead of 45-degree here, you can do say 30-degree here, which makes these two angles as what is 30, 150, 75-degree each angles on the bottom, right? So those are the changes that you can do. But yeah, this is the basic math for the tree. Hope you guys liked it.